Alright guys, so we're going to go through the instructions on how to use the bending light simulation. So you go to FET again, follow the link. And it's an HTML file, so it should run on anything. It might take a little while to load on my computer because my computer is being really slow, so I apologize for that. But essentially what you're going to do is you're going to measure angles of reflection and angles of refraction. So intro is fine, you just click on intro. You don't have to worry about prisms or more tools. And you have a laser here. So you turn on the laser and you can see the laser shines light hitting a boundary. So this is one material up here in the top. Then you see the line, that's the boundary between the top material and the bottom material. So over here in these boxes, you can change those things and it tells you to do that throughout the lab. So I think it starts out with air and water. You're supposed to take note and write down these numbers. You're not going to do any calculations in this activity. Later on, we're going to use Snell's law and you'll do that. Or if you learned Snell's law in the video lesson already, that's fine. You could do that and verify Snell's law, but you're just really recording angles in this and saying what happens in terms of how does it bend. So this dotted line here is really important. This dotted line is the normal, and that's where we measure all of our angles from. So we measure from the angle to where the ray of light or beam of light is. So if I take this protractor here, it's set up to measure that angle. So if we put 0 on that dotted line like I just did, and then you can adjust this to any angle you want. So it's pretty open-ended. This lab, you can shine it at any point. So if I put it there, this looks like it's 10 and then 20. So when I send the ray in at 20, it bounces back the reflected beam, which is the one that stays within the same medium or material in the beginning. So it starts out in air, it stays in air, this part that comes back. That is also at 20 or 19 or wherever I have it at. So I would say it's just at 20. And then what you need to do is you need to measure this angle here. So from the 0 going to the ray of light. So this is like 10, it might be around 15, that's 20 there. So I would write for the incident angle, or theta 1, that would be 20. For theta 2, the refracted angle, that would be close to 15. And what you're going to do for the same material, you're going to change the angle a couple times. So I might put it at like 60 or 65. It doesn't really matter. But you're going to draw some conclusions. That's at 80. This angle from 0 to here is 80. 90 would be along the boundary, and you don't want that. You also don't want to shine it in at 0 because you don't get any refraction there. So you want some angle between 0 and 90 degrees. You change these ideas to different things and different situations between air, glass, and water, and you record the numbers and go from there. So let me change this to air. And as you can see, sometimes it appears like you're not going to get an angle, or like if you're past what's called the critical angle, you're not going to get a ray of light to go into the new material. So what you need to do is you need to adjust until that happens. So now I have the situation that I want. So if you ever end up with an angle, like a situation where you don't see anything getting refracted, just move your laser until you get one that works. So I could put it there, that's at 40. That's 40, and that's like almost 60, maybe 55, 56, something like that. So just change your angle until you get ones that correspond to what's supposed to happen. So don't write like NA, it didn't happen, because like really if you put it past a certain angle, like it doesn't. But we're not studying that. We're trying to see how the refraction works and the reflection works. So make sure you're seeing a refracted beam, which is the one that's going into the new medium, and a reflected beam, which is the one that's staying in the medium. So you want both of those beams of light to be there. Okay, so that's about it. Hopefully that is good, and I will talk to you guys later.